Siri Pathashale. Today we continue with the chapter pair of linear equations in two variables. In the previous class you have learned that what is a linear equation in two variables, what are simultaneous linear equations or simultaneous equations, and also how to frame a pair of linear equations, and what are the types of solutions, I mean situations where we get different types of solutions. These are the things you have learned in the previous class. Okay, now let us start with today's session. Yes, let us recall once what have we learned in the previous class. Is what is the general form of linear equation in two variable. General form of linear equations in two variable is actually ax plus by plus c is equal to 0. So here what is the condition? A and b should not be equal to 0 and a and b are real numbers. This is the general form of a linear equation in two variable. How do you get a pair of linear equations? I mean simultaneous equations are of the form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So what is the condition? Same condition. These are pair of linear equations in two variables or simultaneous equations, and here also condition a1 b1 c1 b1 c1 a2 b2 c2, all these should not be equal to 0. Here c1 c2 can be because these are constants. a1 b1 and a2 b2, these should not be equal to 0, and all these are real numbers. a1 b1 c1 a2 b2 c2, all these are real numbers. Okay, this is about linear equations in two variables. Now, yes, in the previous class I have explained with the help of tiny cats. There are three situations to get solutions for linear equation. Yes, if there may be a unique solution. First case is there may be a unique solution. I mean, so here x and y, a pair of numbers. Okay, x and y with a unique solution. First case. Second case, there may not be any solution at all. Yes, when two lines are parallel, okay, there may not be any solution at all. There is no solution at all when the lines are parallel. And the third case is the lines are coincident. In this case, we get infinite number of solutions. Okay, these are the three situations. So, if we get a unique solution, a pair of numbers, a solution, or a distinct solution or a unique solution, then these lines, pair of lines are intersecting. Only in case of intersecting lines, I mean crossing each other. Okay, only in case of intersecting lines we get a unique solution. Okay, then we won't get, that means there is no solution at all. When? No solution in case of parallel lines. If the lines are parallel lines. Because you all know here linear equation always represents a straight line. So here each of the line represents a straight line. So we get a pair of lines here. Okay, so this pair of lines, if they are parallel, we won't get solution at all, because you know parallel lines never meet. If they never meet, how can we get a solution? It's not possible. Okay, so parallel lines. In case of parallel lines, we don't get any solution. Next, third case is the lines are coincident. Coincident means what? One ಮೇಲೆ ಒಂದು ಸಾಗೋದು. So joining and going together. Okay, going together, lying one on another. Okay, that type of lines are called coincident lines. Okay, so for coincident lines, we get infinite number of solutions. I give an example of tiny cat. They will keep on joining till the end. Okay, so we get infinite number of solutions. Infinite solutions. When is this possible? When the lines are coincident. That means lying one on another. Now, let us learn how to find whether the lines are intersecting or parallel or coincident. When a pair of line is given, suppose that when two pairs, okay, two lines are given, two lines, lines which are linear equations are given, and then how to find whether they are intersecting lines or parallel lines or coincident lines. Because each time we cannot draw the line and find this, isn't it? So there should be some method. Okay, we are going to learn that method now. How to find. And here one more thing you should know. Here intersecting lines are always consistent. Okay, are always consistent. Intersecting lines are consistent. And these parallel lines, no solution at all. So they are inconsistent. Inconsistent. And coincident lines also, they are depending on each other, one on another. So therefore dependent or they are also consistent. Dependent or consistent. Students, you can note down this. This is also given in your textbook in a tabular column. You can go through it once. Okay. Now let us learn how to find whether these lines are consistent, inconsistent, or dependent, or yes, whether they are intersecting parallel lines or coincident lines. For all this, we have same method only, that is comparison of, by comparing the here these which one coefficients of these parallel variables. Here a1 is coefficient of x, b1 is coefficient of y, c1 is a constant in the first line. In the second line, a2 is coefficient of x, b2 is coefficient of y, and c2 is the constant. Okay, so by comparing the coefficients, we can find this. Find whether the lines are parallel, coincident, intersecting, or consistent or inconsistent. All these details can be obtained just by comparing their coefficient. Okay, let us learn how is that now. Now, let us start with an expression, with a pair of linear equations. To find this, I'll take the problem from your exercise only. That is in exercise 3.2. Okay, let us take second main in that. It is on comparing the ratios A1, A2, B1 by B2 and C1 by C2, find out whether the lines representing the following pairs of lines, linear equations, intersect a point, are parallel or coincident. Third one is also same kind. So I am going to show all these the types of solutions as well as types of lines, both with the help of the same main. Okay, second main here. We have three problems. Let us do those three problems. First one, let me take now. So I'll erase this now. Now let me take the first problem in this. It is 5x minus 4y plus 8. 5x minus 4y plus 8 is equal to 0. first equation, and second equation 7x plus 6y minus 9 is equal to 0. Okay, minus 9 is equal to 0. We are going to solve the find whether this pair of lines are coincident, parallel or intersecting lines, and whether the lines are consistent, solution is consistent, inconsistent or inconsistent. Okay, so let us go find it now. Before learning this, let us find, yes, how to find here, how to compare. So just use this rule. Here lines, that a pair of linear equations or a pair of lines are intersecting, or pair of linear equations are consistent when, if it is a1 by a2 is not equal to b1 by b2. This is condition for the intersecting lines. Okay, if this ratio, that means a ratio of a1 and a2 and b1 and b2 is not equal, then we say the lines are intersecting lines and the solution is consistent. Okay, next, this is for first case. For second case, so this is for intersecting. This is for intersecting line. And solutions are consistent. Solutions are consistent. Second case, it is that here if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then this condition, if this condition is satisfied, the lines are coincident line. Okay, coincident means lying on one another. Lying on one another. Coincident lines, and here also we get consistent solutions. Lines are consistent, so equations are consistent. Now for the last case, for parallel lines, it is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is for parallel lines. Parallel. So here this is for parallel lines. Parallel lines. Here the solution is inconsistent, and this condition is for coincident line. Coincident lines, and here we get consistent solutions. The equations are consistent here also in this case. So now let us solve these two pair of lines, these two simultaneous equations, and let us find whether the solution, whether they are intersecting lines or parallel lines or coincident. Let us take your coefficients here. What is a1? First coefficient of x for the first line. a1 is equal to 5 and b1 is equal to minus 4. Okay, don't forget about the sign. a1 is equal to 5, b1 is equal to minus 4, and c1 is equal to plus 8. Okay, this is for first equation. Now for second equation, a2 is equal to 7, B2 is equal to 6 and C2 is equal to minus 9. So now let us check this now. First let us take first case now. A1 by A2. Let us find the ratio. A1 by A2 is equal to how much here? 5 by 7. Okay, A1 by A2 is 5 by 7. And B1 by B2 is equal to minus 4 by 6. Even if you simplify, what do we get? It is minus 2 by 3. It's very clear to say that 5 by 7 is not equal to minus 2 by 3. So, A1 by A2 is not equal to B1 by B2. Then is there need of finding C1 by C2? Not necessary, because here only we got the answer. Okay, so what type of lines are these? These are intersecting lines. So you can write the conclusion. The given pair of lines are intersecting lines. Intersecting. If the lines are intersecting, what do you say about the solutions? Solutions are consistent. We get a unique solution. Here we get a unique solution or distinct solution for these two lines. Okay. So this is first sum. Now let us go for second sum. You finish this. Now let us go with another problem. Problem number 2. Let us take 9x plus 3y plus 12 is equal to 0. And second equation 18x plus 6y plus 24 is equal to 0. 9x plus 3y plus 12 is equal to 0. 18x plus 6y plus 24 is equal to 0. So this is the pair of linear equations or simultaneous equations. Now let us continue with the problem. So let us do now. Let us find the coefficients of this now. What is the coefficient of x in the first equation? That is a1 is 9 and b1 is equal to 3 and c1 is equal to 12. In the second equation here, it is of the form a2x plus b2y plus c2. So it is a2 is equal to 18, b2 is equal to 6 and c2 is equal to 24. Okay. Now let us find the first ratio a1 by a2. So a1 by a2 is equal to, what do I get now? a1 is 9 by a2 18. If you simplify, you will get 1 by 2. Let us find b1 by b2 now. b1 by b2 is equal to 3 by 6. This is also equal to 1 by 2. Yes, we got a1 by a2 is equal to b1 by b2. So we need to find c1 by c2. If c1 by c2 is also equal to 1 by 2, the lines are coincident. If c1 by c2 is not equal to this value, that 1 by 2, then it is not, the lines are not coincident, they are parallel lines. Okay, let us find now c1 by c2. c1 by c2 is equal to, we get 12 by 24. So 12 by 24 is also equal to 1 by 2. So what do you conclude? If A1 by A2 is equal to B1 by B2 is equal to C1 by C2, what type of lines are they? They are coincident lines. That means they are lying one on another. ಒಂದ್ರ ಮೇಲೆ ಇನ್ನೊಂದು ಇರುತ್ತೆ or ಜೊತೆಯಾಗಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. So they are coincident lines, and here the solution is consistent. We get infinite number of solutions. In case of parallel lines, we don't get solutions at all. When the lines are coincident, we get infinite number of solutions. So here what is the conclusion? Conclusion is here these lines are coincident lines, and we get here also infinite number of solutions, and the lines are the solution pair of lines are consistent. Equations are consistent. So this is the conclusion. Now let us go for third example. You finish this. Good evening, Vidya. Thanks for joining. Okay, now let us take third example. Third example. Let us take example 3. 6x minus 3y plus 10 is equal to 0, and the second equation 2x minus y plus 9 is equal to 0. We have a pair of linear equations into variables. Now let us take the ratios. As usual, a1 by a2 is equal to, yes, what is a1? 6 by a2 2. So answer is 3 by 1 or 3. b1 by b2 is equal to minus 3 by minus 1. Here, because there is no number here with y. Okay, so along with y there is no number. That means what? It is nothing but minus 1y. Okay, so coefficient is minus 1 here. Minus 3 by minus 1. So answer is minus by minus plus, it is 3 or 3 by 1. Ratio is 3 by 1 or 3. So we got a1 by a2 is equal to b1 by b2. So we have to check with c1 by c2 also. Okay, because they may be, the lines may be parallel or consistent. Okay, so by these two ratios we cannot decide anything now. And now let us C1 by C2. C1 by C2 is equal to 10 by 9. Yes, 10 by 9. So we got a different ratio here. 3, 3. Here we got 10 by 9. Now what do you say? Here A1 by A2 is equal to B1 by B2. Yes, but it is not equal to C1 by C2. Okay, so A1 by B2, that is A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. So what do you conclude about the lines? These lines are parallel. When the lines are parallel, we never get a solution at all. They are going parallel only. They never meet. Only if they meet, we get a solution. We get a unique solution. Here, they never meet. So we get inconsistent pair of lines, and the lines are parallel. Parallel lines and the solutions inconsistent. inconsistent, or no solutions at all. Okay, no solution. So by this you understood that here how to find the different situations where we get the solutions and how are the solutions and how are the lines. Just by comparing the coefficients of the lines, we can find whether the lines are intersecting, parallel or coincident, and we can also find that whether the solution is lines are consistent or inconsistent, and we can also find that yes, whether we get solution, that means whether it is unique solution or no solutions at all or infinite number of solutions. So these are the things you have learned in today's class. So let us end today's session. Thank you children. Thanks for joining. Bye bye.